Hello, synchronization 3, 2, 1, boom. Hello, in this video I'm going to explain the meta table. I think that's the most useful feature in Lua. Yeah, let's go to the video. I hope that you are familiar with OOP or classes from other languages. Otherwise, this can be hard for you. I'm going to tell you how to implement the classes in Lua, and I'm going to give the brief explanation to the people that are learning. So that's the way how you create a class inside of the Lua. You get a table class, you put this thing, I will explain later. You create some functions, you assign the meta table, and you return self. So that's our look. So let's create a pistol equals pistol class.new. We're going to put the workspace.tool. In our case, that's just a part grouped and named tool. And we're going to name it eagle. Yeah, then we have a method called shoot in that pistol. So we call it like pistol column shoot. We put in column like in the same case like workspace WaitForChild. You see, you put in column here as well. I will explain that as well later. So now what it does, we have to assign self.name equals name, self model equals model, and it's going to say like self.name shot. Okay, let's run it. You see? Eagle shot. It has outputted our name that we gave to the pistol. Now let's explain step by step. So the brief explanation to the classes will be, there's an object, it has some data like name model, and we have some function to process the data. The data can be changed, the data can be output, processed, whatever you want to do with that. That's basically just to store some unique data, because we can have two pistols, like local pistol2 equals pistol class new. We're going to put the same tool because it doesn't matter in our case, and we're going to call that pistol like this. And let's shoot from the other pistol right now. So I didn't change something here. I'm going to run, and we see that our second pistol shot, but the second pistol has another unique data name. In our case, in first is this, and another this. And let's shoot from two pistols at the same time. Yeah, we are cowboys, we can shoot from 5 pistols. Let's uncomment this, run this. You see, we got 2 pistols shot. So in our case, we have the class itself, we have methods, and we have the constructor. That is the function that will return the empty table with some values assigned. So that's not empty. We have a value name, it is string. We have model, it is model. Yeah, and we can access to each of that. Let me start the game pistol. So as you see, we can access the data, for example, shoot. Yeah, the functions that we need, name, model. We can output the name bar ourselves. The object has unique data, and it has like global functions to process the data. So we put in the pistol inside of that function, it takes the argument called name, and it prints it. So in our case here, that will be basically the same thing as we're doing here. We take in the pistol and we take in .name. Yeah, we got eagle, the name of the first one. About meta table, how it's working, let's go deeper and deeper in that. First, we create in the table, the empty table, and we put in the meta table, the pistol class. So the self in our case is just a normal table, and we set in the meta table of self to the pistol class. Then we have the meta method called index. We'll explain that later as well. That means we're searching for something. In this case, we're searching for the function called shoot. It goes to the self, it looks for it, but it found nothing. Then it remember, aha! We got meta table connected to that self. Let's go search there. So it goes to the meta table. It goes to the index. That's important. Remember that. It goes to the index. It doesn't go to the table itself first. It goes to the index. And then it goes to whatever index is. Pistol class. So we can have another table, for example, called local pistol functions. Like this. Then we're going to do pistol functions dot shoot. In our case, put in self. And we're going to print nope. Like no shooting. And instead of the pistol class, we're going to put the pistol functions inside of the index. We have 2 pistols, yeah, shoot, and we have the table with functions. That function has another function, shoot. So run it. Both cases, nope. That is not to be confused, maybe. I will remove the line 24, because you see it's line 24, it was another case. So it goes to the index, it doesn't go to the table itself. This table has the function shoot that will print the name of the object and will tell that object shot. And we got another table with functions that just prints nope, it doesn't shoot, the safe pistol. Let's remove that thing and go a little bit step deeper. In our case, let me change that thing again to that. So we just creating the table, we setting the main table, meta table to that table, and we returning table and assigning self to the table. Why do we use self? It can be confusing. Self doesn't matter in our case. It's just a variable. So we can rename self to everything we want. We can rename something. We can rename this to something like this, like this, like this. We put in something like something as a table, something name, something model, and we return in something. In our case, this is something and this is something. Run works. Why? Because self is a variable, like something. And we put in self just to get this fancy highlight. Yeah, it sometimes can help. And in the functions, we put self to process the data of the object. We have to put that object inside of the function. It cannot access the data if we're not putting the object itself in that function. So we put in self here. We can use as well another variable, something. We always use something. And we're going to say that something.name as well works. Then why do we use self in the functions? So now we got pistol. If I put column, yeah, it output the same thing. It's just for fancy highlight. Okay, let's put the self like this. And let's look at this. You see, pistol column shoot, pistol 2 column shoot, but our function accepts one argument. It doesn't disappear. What the hell is self? So we can call that function by two methods. We can use the class itself, so pistol class.shoot, and we're going to put it inside. If I run, you see, it works. So why don't we put the pistol here? We can, basically we can. If we change this column to the dot and we're going to put the pistol too, it is working. Yeah. Why do we put column? Column means that take that object that we call in function from and put it as the first argument. So it takes that pistol and it puts itself inside of that function just automatically, that we don't need to write it each time. Sometimes I prefer to call the functions from the pistol class itself. You know why? Because if you take in that object somewhere far away, scripts, local scripts, module scripts, it went through all of this. And we don't have the suggestions anymore. But what do we have? We have class. And class had functions. So pistol class.shoot, and so on. We put in the pistol inside. Run without errors. So we got this. Basically, we don't need that setup meta table in this case. Because set meta table allows us to call the functions from the object. Like, take the object and call it directly. If I remove this, I run this, works as well. Why do we use set meta table? Let me put the set meta table here. Oh no, let me remove it and uncomment this one. I'm calling the shoot from the pistol in pistol 2. If I run, I got an error because it didn't find the shoot. In our case, what set meta table does, let me set meta table just to the pistol class. So we searching for the function shoot. Go to self, no shoot. Then meta table, it goes to the meta table, goes to index, shoot, we found it. We use it. So let's go deeper. Now it goes advanced stuff. The meta methods. What the hell is this? We got a bunch of them. Like if you open documentation, we got add, multiply, concat. We will use it. So now index. What the hell is index? Index is a function that takes the object itself, this object, and takes the index, whatever we're indexing. It executes like when we don't find the method. Within this, it goes to this, index, voila, and we executing something. In our case, we're doing like like pistol class index. Yeah, we're returning this. I run this, works. We can execute the functions like if we're indexing something or hide something, like print index. We're running this and we got index here, shoot, and index here, shoot as well. But not in these cases because this pistol class is just a table with functions and we indexing directly. In case with pistol, it's an object. It doesn't have that function. So it goes to the meta method and executes index. Meta table, it goes to the meta table and executes the index function. If you put the table, it just goes directly and indexing the table. So we can prevent this from happening. Like if index equals to shoot, that's just a fancy way, never use that. So I'm going just return an empty function and run, nothing happens. We need to maybe remove this. Nothing happens because index is shoot and we're returning empty function. Be careful with that. If we're doing self index, what's going to happen? Guess. Self doesn't have the index. It goes to the index and it puts in self. Again self. Self doesn't have index. it goes to index. And that's recursion, like infinite recursion. In that case, run error, stack overflow. Too much of the things, because self, goes to index, goes to self, go to index, and it's looping until the error. Be careful with that. We can use the pistol class or some fancy method like row get, like this. So we put in the self as a table and we put in the index. What it does, it bypasses every meta method, like index, so on. It bypasses it, like through. I will not recommend to use this in this case because, yeah, we take in self and we index in self, but self doesn't have that index, like it doesn't have the shoot. I run, error, missing shoot of the table, you see? So we cannot use row get in this case, we using just pistol class, remove pistol class, square brackets, index, return the method, execute it. Let's explore another method. Let's make something like baby generator, it will be fun. So in our case, we don't need pistol anymore. Yeah, let's remove the pistol, local human class, human class equals to this, human class dot index equals human plus. Maybe you can do the templates with that, like plugins that you don't need to write it manually. Yeah, you can create the functions to that table with function or human class dot name equals function, like I did. I just separate this constructor and other functions, easier to read. So human class dot new, we're going to create self this, set meta table, a table we're going to put to human class, return human itself, self. Okay, we're going to give the name, it's string, self.name equals name, like this. And I'm going to create a method called tellAge. Yeah, tellAge equals function, we pass in self again. I will explain the benefit of using this, just putting self within this function, why it's more beneficial than any other fancy methods that you will find in the internet. Yeah, of course, there are more than this, just two. And I'm going to print self.age. We don't have age, it's going to give us nil. So self.age equals something. Age, in our case number, we put in the age here, returning self, age, printing age. A fancy way, string.format. Hello, I am %s. %s is just passing the string. That's another video. So I'm telling my age here. Let's create a human one. Human one equals human class.new. We're giving it a name called Stefan, and we're going to give the age of 18. And we're going to create another human 2, human class.new, going to call it Sophie, and going to give the age of 19. Of course, we can do human class tell age, and we're going to put the human, and we're going to do human tell age, human 2. Yeah, you see, sometimes it doesn't give us suggestions. In this case, tell age, you see column, and I'm putting tell age, doesn't give anything. If I do human class tell age, human 2, it gives us suggestions that the function exists. How we can check it? If we do something like this, column, let's tell egg, I don't know how to read it. And I'm going to do this, we getting nothing. Like here should display this thing. If I put the age, we get in this suggestion that function exists and we can use it. So we telling age, run it, see, it's working, 18, 19. Let's do another method called multiply, because humans are multiplying. Mul equals function, human 1, human 2, and we're going to create another human. Let's create another thing, local names equals Stefan, Sophie, that the parents will maybe call their child like by their names, Fred, Bob, Adonis. Yeah, so we got the names, then we're going to pick a random name, name equals random.new. We're going to take next integer from 1 to hashtag names, so the amount of names we get in the random index, let's call it index. And local random name will be names and random name index. In this case, we're going to return human class dot new. So we're going to tell the random name and we're going to put h0. So we're going to choose the random name and let's print here fancy way string format %s was born, and we're going to put random name like this. So we're going to create another human, let's call it baby, and it's going to be human 1 multiplied by human 2, and we're going to do baby. Yeah, it doesn't tell us anything, you see, no suggestions. Human class tell h baby run. We got our new baby. Let's just human tell name. Basically that's the same function, let's just copy. But in this case, we're going to put the name. And here we're going to tell the name of the baby. The baby going to introduce itself, very big baby. And we got Fred. So we got our baby, the humans are multiplying, and we can do something %s. And now I run this. Adonis! The baby is Adonis. Finally they chose the right name for the baby. We export this meta method, multiplies it. Means multiplication. We have another methods like human class concat. Just let's take this function and let's remove this thing. So we're going to return human class new. We're going to just concat the names. Human.name, human name.this name, and we're going to put h human1.h plus human2.h. Okay, now let's call it local mutant. We got something like mutant, and mutant will be in our case human1 concat human2. And let's do human plus tell name mutant. Concat, we have to write it fully. So concat. We write this. Hello, Stefan Sophia. Oh my god. So now why the benefit of the putting self within? If you know the types, that will be very easily understood by you. We got type called human. We can call it whatever we want because it's just visual. The human got name is string, and we got age will be the number. Let's put this human on top here. Type human. What we're going to do, we can say that self is a human. And right now we get in the sweet suggestions, like you see .name.age. In this case, if I do human dot, you see we got a lot of methods. New, tell age, tell name, age, multiply index. We don't need this multiply index concat. We can say that it has a couple methods like tell age will be the function that passes the human inside because it's self, and it's going to return us nothing. And then tell name, it's going to take again human and it's going to return nothing, nil. Now if I check the self, I got tell, you see tell age, human, nil, so on. And column tell age, tell name. Why do I put the human inside? I remove the human, you see tell age. Now if I put the column, we got only tell name, because for the compiler it knows that if it passes itself within that function, it should be executed as well with column. So now tell age appeared. Where we can use the type, for example, we can say that the constructor will return us the human. Now we telling that human is a human. Here we get the type. It's just basically for us. If we made a mistake inside of the type, it's not going to count. So name, tell age, we don't get like any other methods. And here we can say that human is human. Here human is human as well. And again human, and again human. So now maybe we can get the suggestions for baby. Yeah, baby is error type. We can say that baby is basically human. This double column means that we exporting the thing as a human. So we can tell that the baby is a human, then we got baby dot name, tell age, tell name, or we can tell that human multiplied by human 1 by 2, it will be the human again. We got the suggestions. Yeah, sometimes you can just use the brackets and tell that everything that inside of these brackets is human. Otherwise, it tells just the human 2 is human. So you can go to the documentation, you can explore the things here. Umnary operator, additional, subtract, multiply, division. Division is floor division, yeah, that it floors the value of this module. Power, let's use another method called add, maybe that will be useful. Human 1, it will be human, and we're going to put the age will be the number. In our case we can add like everything we want to the human, but we need to restrict it to the number. So we making assert age type of age equals number, otherwise tempt to add woman and number. We get in this errors if we adding, for example, cframe. Let's print 1 plus cframe.identity. That's basically cframe 0. I put this and you see invalid argument cframe expected good number. And we're going to do human.age plus equals age. What we're doing here, let's test on the our human1 plus equals 15. It's going to give us an error, I believe. We don't tell in age of the human, so let's do human tell age and human2 as well tell age. Let's tell the name, maybe we need this, tell name, and human2 tell name. It's going to give us an error, I believe. Yeah, index tell age, because human we're not returning anything at all. What we can do in this add, we can do like human class. Let's just return the human. So we taking the human, we taking the age, we adding the age to the human, and we returning human. Or in the better way, I will do the better way a little bit later. Yeah, you see that Stefan is 33 years old. He's very old. We will do the more proper type. So we're going to return. We will remove this one. We're going to return human class.new human1.name human1.age plus age. I press run. So we're creating another Stefan, so that it's a Stefan from another universe. We add in and we, for example, let's just try to add 15 as a string, and we get in the error like, oh, wrong error, something else. Error. Human and something else, not number. Let's tell about the methods of this. Let's just not tell that the constructor returns are the human. Let the Roblox guess whatever constructor returned us. So we got Stefan and Sophie again. We getting access to every method within this table. So this table has the methods like concat, add, multiply, index, la. That's for the set meta table. We can use it, by the way, still use it. Then we got function tell age, tell name, and we got another function .new. So we can create like another human3. Local. Going to use human1 as a parent, or not parents, like we're going to say that it's going to call fkl. I don't know who called the human like this, and it's going to give the age 12. The very modern rapper boy. Yeah. And we still get human1, human2, human3, so we can call the methods from the class itself. And human3 tell name. Yeah, it's working. It's working. It doesn't say that the parent of it it's human1. No, we just call in the function from the human1. So it goes to the meta table, so human class, and it search for the function called new. And we created another human. That thing we can meet in the normal instances. So the instances, let's look at the workspace. Yeah, column, it has WaitForChild. Clone is la, so many functions. If I put dot, I don't see that functions anymore. I see another thing. So that is masking by type. Yeah, if I put again that human, again, let's just comment the workspace. So right now, it doesn't tell that we have the function new, neither in the suggestions nor everywhere. I run this, fkl exists. Why? Because we hide in the methods with types. So it just basically for compiler, like to tell us suggestions, whatever in this human is, like age, name, nothing else. New is not exist. Fake information, misinformation, but it exists. It exists, believe me. So let's explore the function called WaitForChild in workspace. We do in WaitForChild and we put in name, tool, camera, baseplate. Let's change the column to the dot. Aha, it's working. What does it mean? That we can do something like workspace.tool and we're going to search for the part. Yeah, it doesn't display as suggestions, all the suggestions, but we're going to search for that. And I'm going to print it. I will take this and I'm going to put this into output directly. Part. We got the output. You see? Part. What does it mean? That we can call the functions for other things, that we passing itself in that function. Yeah, and it searches and it takes the data, for example, children, and it search for the children with name called part. That means that we can, for example, search for the atmosphere. It is not related to workspace. Game.lightning, and we're searching for the atmosphere. Atmosphere, I print this, it works again. I can do like this, atmosphere. I run this, atmosphere. So we get in it. We just put in the object inside and it uses some functions to take the children and look for it. So if I do workspace this, let's just put the timeout on 2 seconds. I print it, it didn't find it. No, because in workspace, it doesn't exist. Game.lightning, I put it, it exists. Here, atmosphere. We can do a lot of things with it. So again, with masking, so we can create another weird type. Let's call it type workspace with big letter W. Yeah, workspace, it's basically workspace. And let's tell that the workspace has another function. Say hello. It's going to take as an argument workspace. Not this workspace, because type of the workspace is big letter. And it's going to output us a string. Self-recursive. Then we tell in that workspace, local workspace is workspace, but we export in this as a type. Yeah, wait a second, it is recursive. So we just get rid of that. It is workspace. Workspace is now workspace. And we tell in that workspace has method say hello. Like, what the hell? We can tell, of course, like, I just call it with small letter W. Then let's just put the workspace here, workspace M. That's basically the uniting of two methods. It takes the methods of this, and it says that it has as well these methods. I don't remember if we can do this. Yeah, or, like this. Let's just take this one, and we're going to put it here. Let's remove this thing, tell that it takes this, puts it here, workspace, column, say hello. This method exists, but if I run this, error, because say hello does not exist in the workspace. It's just a mask of methods. Let me just show what is the thing. I don't remember how this is called. For example, we got type person. The person has an age of number and it got a name, a string. But we got another type called Discord user, and it's going to possess some properties of the person, and it's going to add another things like roles. It will be the table of the string. So if I'm creating some variable human and I'm going to tell that human is a person, yeah, the compiler going to tell that human has an age and name. If I going to tell that human is a Discord user, it's going to tell me that it has name, age and roles. Yeah, you see roles, and I'm gonna index maybe, but it's going to give an error because human is nil. Types is just that you can understand by yourself that compiler has an idea what it should to suggest you, and we can do whatever we want with that compiler. It doesn't stop us. So let me now explain another thing about the tables. The most important thing, if we pass in the table somewhere, what's going to happen? Like we got test equals this table 1 2 3, and we got a function like print table. Local function is going to get a table, let's call it, let's say that it contains numbers, and it's going to print this table. I'm using underscore just not to mess with table. Yeah, and I'm going to print this table. What you think going to happen if I call the method print table on test? Is it going to put the clone of the table inside of the function, or is it going to put the table somehow in that function? It's going to do something else. So the table is a pointer to the table. It's not a table itself. Just to understand what does this mean, that means if I'm putting the table somewhere, yeah, I'm not cloning it. Basically, it's just something like putting itself inside of the function, but it doesn't put the entirety of itself inside of the function, but it puts the pointer. It's like an address where to go to get the table, a memory address. So I'm putting this memory address inside of the function. It looks for the address, it goes to the address, and it takes the table itself. So if we create the table, we're creating it only once. If we put it inside of the function, we don't clone it. We got in the print table, so print table, copy that, execute it, table 1 2 3. Let's just do like table.unpack. That we don't need to open it this each time. And let's add another function called remove first element. It's built the function, again, table, it's going to be the number, and we're going to tell that, hey, table, remove the table and position 1. Then we're not going to return anything at all, yeah? We just took the table, we put this inside of the function, and we're removing the first element. Now, I'm calling that method called remove first element from the test, yeah? Look, 1 2 3, then I'm not returning it, and I'm taking the table and I'm just printing it. Let's print. 2, 3. We lost one because it put the table inside of that function, removed first index. That's it. We got only one table. We're not cloning it. That will be also important to this. So if we got another variable called test2, very original, and it's going to be the test1, because we're not cloning the table at all. How we can clone the table is table.clone, but we're not doing this for now. If we're putting the test to the test2 as an argument, the test2 not going to clone the table. So it will be basically the same table. We taking the test2, it's basically the same table. We putting inside of the remove first element. Test2, you see, it's like two different variables. And we printing the test like the original table. I'm taking this, print 2, 3. Again, it removed first element. We don't have the first element because we removed it. I can comment this, so remove this like this, print 1, 2, 3 again. It is the same table. We can do like a lot of things with it. Maybe we can do something like this. Test first equals test. Yeah, it's going to be confusing. Maybe if we clone the variable each time, it will be the mess. Memory of all our computer, boom boom. I can do that. I can put like the table as the first index of itself. And I'm not going to remove the first element this time. And I'm going to print the table like this. Print table, another table. I open this table, cycle reference detected that it goes to itself, it goes to itself, it goes to itself. Thing with this, like we put in not the table itself. We put in the pointer to the table. That means the memory address. So we're telling that first element is just the address of the test, and if we go into the first element, we coming again to the table. So we're not like creating an infinite amount of memory from this, because it's going to crash. We're just going again to the table, again and again and again. What we're going to do now? Let's explore the superclasses. That's more harder. So we need to remove the table. Yeah, we can do a lot of things with the table. For example, when I made my Huffman encoding, I made something like local original data, data and local branches. In branches, I have like some list of tables. This. What I did, I just took these tables, I inserted them in branches, I insert these tables in the original data, I made something in branches with these tables, for example, removed 2 and created another one, remove this 2 and created another one, but the original data is still here. Like, it's the same table. Maybe it's somewhere inside of this table, somewhere deeper, but we got the reference to the original table. We got the address and we can do something to it. For example, if we change something in branches, it's going to automatically be changed in the original data. So here 133, if we go in somewhere very deep in the branches, we change in the, let's just do this right now. Local test equals 133. If I'm taking this test, I'm putting the original data here, I'm putting in the branches, I'm going that branches first, and again first element will be 3 again, and I print in the original data first one, I take in this, I put in here, I'm looking at the table and you see 333, another table, but it's the same address. So we change the element and it changes the table. So let's now go to the superclasses. Let's remove this thing and just go again and make a pistol class. Index equals pistol class, and we're going to create another table called local base weapon. Like this. Base weapon is going to look again at itself. Base weapon, of course, we need to do this. Base weapon, then we're going to put the constructor inside of the base weapon. It's function.new, we're going to put the model will be the model, we're going to put the name will be the string, a local self, again the fancy things, set meta table, this new table to the base weapon. Again, we creating like the same table, so if we're not copying it, we're not doing something bad with it, so we taking this table and we are returning it to self, so that's basically the same table. Again, let me just put this thing for now. So self, again table, and we can do set meta table self to base weapon like we did before. Like previously I showed the function with remove first element, so we put in the table here, we making something with the table and the changes are still within this table, so we put in the meta table to the table. So we're going to create an empty table, we're going to return that empty table, we're going to tell that self.model equals model, we're going to tell that self.name equals name. Yeah, we're returning self there. We're going to create another constructor function pistol class dot new. We're going to put again model and name, model name string local self. What we're doing in this case, if we want to like have the methods from the pistol class and have the methods from the base weapon. Base weapon in our case will be the superclass. Method will be base weapon tell name function. It takes self and prints string format %s as name %s. So we're taking self.model.name. We don't have suggestions. Of course, we can create a type called base weapon, tells that base weapon has model name. We can put here that self is a base weapon, and we're going to get these suggestions. For now, let's just go without this table. So we're going to put the model name and we're going to put the self.name like this. And we're creating another function pistol class dot shoot equals function as well. This putting self string dot format. We're going to put in our case %s shot, and we're going to put self.model.name. We cannot put the model because it's going to give us an error. It cannot format the model, like take the model as a string, because model is instance. If we take in print like workspace, I'm not putting the name, right? Enter, it outputs the name of this, but that works only with print and so on, so on. It doesn't work with format, I believe. String.format %s, and we're going to put the workspace. Yeah, error. We cannot put this. We can do like workspace.name, and it's working. Workspace. Now shoot. What we're going to do here to access the method shoot and tell name. First, we need to put the meta table to the pistol class. So we set in the pistol class, and we set in the meta table base weapon. Pistol class as a subclass, and we set in the meta table to the pistol class, which is base weapon. That is base weapon, yeah. We set in the meta table, so, and here got index self. In this case, we're going to change the meta table of base weapon.new. We're creating the constructor of the base weapon. That's going to be model.name, and we put in the set meta table to the pistol class. We're returning self. What it does, so if we call in the tell name, first it's going to self to the object, it looks for it, it doesn't find it. Then it goes to the meta table pistol class, to the index pistol class again. Tell name, didn't find nothing. Oh, another meta table. It goes to the base weapon, it goes to the index, and it finds the function, and it brings that function over here. In this case, why do we use base weapon.new? If we got like a bunch of subclasses that have model and name, we don't want to create the constructors that will going to take this model name and going to put it again and again and again. What is here? We created empty table, we set model, we set name, then we return the table to the pistol class. We took the table, again, that thing is a table. This table that we put earlier, this empty table, and we taking this empty table and we assigning another meta table to the table, so pistol class. And how we getting like class integrity, I believe, I don't remember that word. So you go into pistol class, if you didn't find the method, it goes to the meta table. So this object goes to self, looks for method, didn't find. Meta table exists, goes to meta table, index, didn't find method. Meta table exists, goes to meta table, index, method. Let's create local pistol equals pistol.new, pistol class.new. We're going to put workspace.tool. We're going to put name eagle. Again, we have now method called tell name, but the Roblox compiler will not tell us that we have that method because we have to put the type. If I do like, oh, it does have like tell name, you see, pistol class. It's not going to tell us that it has the method shoot. Yeah, so if I write shoot, doesn't have. Shoot, no suggestions at all, but this method exists. Like, it's pistol class, we reassign the meta table to it. It believes that a base weapon is the original table and it belongs to the base weapon, but it doesn't anymore. It belongs to the pistol class, and the pistol class belongs to the base weapon. So it's a child of the child. That's a grandfather or a grandmother, whatever you want to call it. Now I press run. Shoot, you see? No error. Shoot works because shoot exists. We can create maybe the type pistol that will tell that we have the function shoot, that it accepts itself, and it's going to output us nil because we don't return, we basically return nil. What we can do, we can assign another value or override the old one. So we have here model name, as you see. We can tell that we have bullets. Bullets 5, or we don't have bullets and we need more. So we have bullets, like 5 bullets, pistol dot, it's not going to output us suggestions bullets. So we have to create another type to display this, pistol bullets, run 5. Let me show you the type. So we're going to create the type called base weapon. It will be a table with model will be model, name will be string, and then method tell name will be this. We're going to accept the base weapon function, and it's going to return us nil. And we're going to create another type called pistol. It's going to be the base weapon again, and we combine it with another thing that we created. So this has bullets. Bullets will be number. And we got method called shoot. It's going to take itself, pistol. It's going to output us nil. It takes pistol and it outputs us nil. Now we can tell that self is a pistol. Here we can pistol. We can tell that self returns pistol, that set meta table is a pistol. We can do pistol.new equals function is, and we're going to put this into parentheses, and we're going to tell that we output this as a function that takes model as a model, name as a string, and it outputs us pistol. So we know that that is definitely a pistol, and we hover over this, still any, wait a second, pistol.model, name, tell name, shoot, bullets. So we got everything of the pistol and base weapon. Let's just remove all of this confusing stuff. We can just tell everywhere that we are exporting this as a pistol, but that thing will be enough. Oh yeah, and we can tell that self is a pistol. We missed one. Self is a pistol, we return the pistol. Now pistol dot name shoot tell name. We can create, be careful, maybe we can create something. Test number accidentally maybe, and we're going to see like pistol.test. It says that that is a number, but we don't have the test here nor here. With that, yeah, we can trick the compiler, maybe. So we got pistol, we got this. Maybe we can explore another meta method, but I leave that up to you. Where we can experiment here, we can put the base weapon here. And now if I do tell name column, tell name shoot, same thing. So that's types are visual. If you got another script, for example, that will tell us types, yeah, you got module script. Let's put the entirety of this inside of this module script. Let's call it weapon class, no, just pistol class. Pistol class, Ctrl+C, Ctrl+V. Then we're going to remove this one, and we're going to return the pistol class. We don't have access anymore to the base weapon. Yeah, we can call it class itself. Again, let's just do beam. Really fast. Here, base weapon class. So we're returning class. How we can export the types? We just write in export here before the type here. Now if I go to the script, I say that the pistol class equals to the require script.pistol class. Yeah, and we create a new pistol equals pistol class.new equals workspace.tool, and we're going to give it a name eagle. Now pistol.name should tell name. That's because we said that this function outputs us a pistol. We can remove this. Now we go to script, we look at the suggestions, model, tell name, index we don't have from the pistol, so we don't have bullets and we don't have shoot. What we can do, we put the export type. Now if we require that model pistol class, we can tell that this will output us a pistol class dot pistol. That type is only inside of this module script. So we named this module script as a pistol class. We can rename it like pistol classes, and it's still going to work, like no error. Pistol.model should name tell. You see all the suggestions here. Let's do this, and we can do like pistol shoot. I run, I got an output. That was the metatables in Lua. Wow. Yeah, so if you're learning basically Lua for game dev or whatever you're doing right now, maybe not Roblox, maybe you don't know what the Roblox is and you're looking for the metatables, that was it. Hopefully you like it. If you like this video, you can subscribe, you can leave the comment below, like what tutorial should I make next or what should I make interesting for the YouTube. Thank you for watching, hope you enjoyed. You can watch another video here, maybe it will appear very interesting one. So, and for now, bye bye.